Hi everyone. Okay, I'm skipping around a couple of videos here because FP03 and FP04 were supposed to be done for factoring third degree polynomials, and FP04 obviously for fourth degree polynomials. So I want to do fifth, but we got a little bit of problem here because Titan was in here and he left. Hey, what are you doing? Hey, don't chew on that. Come here. I got you a bone and everything. Come here. Come on. Go inside. Come on. Let's go. I got your bone. Come here. Look, there's a bone right there. Look. Say hi to your audience. Hey. There's your bone. It's the next one, Walker. No, it's big. Let's see if I can get through some of this video. It should be relatively quick after that. Okay. Because he's totally disinterested. All right, so when we talk about factoring and solving fifth degree polynomials, the one thing we want to keep in mind is nothing really changed from factoring third and fourth degree and so on and so forth. So for both of these, we're going to be factoring something out first. And on both of these, we can factor out an x. So we're going to take an x out of this one, right? So then we have x to the fourth plus 9x squared plus 14. Now, that x is going to stay there, obviously, because 0 is going to be one of our roots. But the fourth degree... Hey, what are you doing? Come here. Hey, you're back. No. 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 Come here. Come on. Come here. Take this ball. You want a treat? Come here. Come here. Come here. Woo. Tissues. Woo. Okay. So you stand up. Now. All right. I don't want to do this video again. So anyway, yeah. Okay. So we talked about doing the U method here, and that's what I want you to do. So the x stays to the side. We're going to replace every time we see an x squared with a u. So this will be u squared plus 9u plus 14. Now we can factor this with inspection. I know I need a 7 and a 2 because I need to get the 9. They're both going to be plus signs. X stays here. Now that I have my binomial after I squared it or I factored it, I can put the x squared back. Can you please not? Can we not do that? Can we not do that? That's not for doggies. It's not for doggies. Okay. So here we've got an x squared plus 7 and an x squared plus 2, right? And then you're going to factor it completely because that's not factored yet. I'm going to go quickly with this one because he apparently likes exclamation markers. Hey, you don't chew exclamation markers, okay? Ew. Goodness. Okay. So my zeros are going to be 0, I root 7, negative I root 7 because they come in pairs, and then plus or minus I root 2. Okay, so that's 1, 2, 3, 4, 5. Remember, the fundamental theorem of algebra says a polynomial of n roots or n degree has n roots. So I need to have 5 because it's a fifth degree polynomial. Also, make sure that you're aware of the beginning process to solve these. These two just happen to be greatest common factor method, which also turned into the U method for the fourth degree polynomial. I mean, that's pretty much it in terms of factoring and solving these suckers. Remember one other thing that's really, really, really key too with the fundamental theorem of algebra. The number of complex zeros for both of these needs to be 5. Meaning complex, meaning real, right? Or has a complex part to it. Okay, the possible number of real zeros, this is important. Is either 5, 3, or 1. The reason is because the imaginary roots need to be 4, 2, or 0. And the reason obviously because they come in pairs. So my imaginary zeros, the possible number of those, needs to be conjugates of each other. So there's an even number amount. It's either 4 of them, 2 of them are 0, which means that the real zeros can only be odd, right? And that process continues throughout the course of our factoring. Let's go ahead and just going to give you the answers for this. So again, these 3 lines suffice for both of these functions. This will factor to x, hopefully you did this, It'll factor to x and x squared plus 6 and x squared minus 6, which will give me zeros of 0 plus or minus I root 6, and then plus or minus root 6. So I've got my 3 real zeros, and I've got my 2 imaginary zeros. And that's how we will factor and solve 5th degree polynomials. The other one we can do is, so a 2-term, we pull out. A 3-term, we can use greatest common factor in the U method. The last one we didn't talk about was a 4-term, right? But Titan's eating everything in here, so I'm gonna have to call this a day. If it was a 4-term 5th degree polynomial, I would group like normal, okay? Just remember that the quadratic formula will help you out as well, especially with the U method if something doesn't factor easily, because we're always looking to get those imaginary zeros, right? See ya. Say goodbye, Titan, you bum. Oh, I want to chew everything today. Thanks for making a 6-minute video out of something that should have taken 2. Bye.